Hello. So today I'm going to be going over question 3, part B from our homework assignment 2. So to reiterate the question, our goal is to make 1,000 units per day. However, there are some things that come along with that. So if we make more than 1,000 units per day, we must pay a carrying cost of $1.50 per unit. And if you make less than 1,000 units per day, you must pay a penalty cost of $5 per unit. So the big question is, should we make the product using a single machine whose output is discrete and uniform that outputs an average of 1,000 units per day? Or should we use a workstation that contains 10 machines that each output 10% of the one large machine? So in this case, each machine would average 100 units. And then we're going to just provide these deliverables, and we'll go over that once we get into it. So let me jump into the simulation. So on the left side here, this is the single machine, and we've replicated this 100 times. So over here, we just have random between 0 and 2,000. So the middle of 0 and 2,000 is 1,000. So that's what we anticipate the average to be. We've done this 100 times. And in the carrying cost, we have an if statement. So we say if this machine outputs greater than 1,000, then we will find the difference between the machine output and 1,000, and then we'll multiply that by 1.5. If this is not the case, the carrying cost will be 0. So in this case, this machine's outputted 972 units, which is less than 1,000. So there will be no extra, therefore no carrying cost. However, when we look at the penalty cost, it's the opposite. So if they did not meet the 1,000 unit goal, we're going to take the difference. In this case, it's 28 units. And we're going to multiply that number by 5, which gives us a $140 penalty cost. So our total cost in this case would be $140. And we do that for each of the units. And so to look at one that's extraordinarily high, they completed almost 1,900 units in a day. So although that's great, there's a large carrying cost associated with that. In this case, we see that they pay over $1,300 for their carrying cost. So just looking at the simulation, there's a large variation. We have numbers like 27, 1,700, and that's what you get when you only use one machine. You get a large variation because it's between 0 and 2,000. Looking at the 10 machines, we do the exact same thing. However, what we do instead of 0 and 2,000 is we do between 0 and 200. So it's much smaller, and we do this over 10 machines. And then we sum the 10 machines to get our daily total. So then once we get our daily total, we do the exact same thing for the carrying cost and penalty cost. So in this case, they completed 884 units. They're well short, so we just multiply the short units by the penalty cost, which is $5 per unit, and we get the total cost of $580. As you can see, the variance in this is much smaller. Although we have this is a number that stands out. We have 1 unit for here. And then while others we have, right below it, 168 units, 192. These they don't count for as much because that's only 10% of the total. So, once one gets 1 and this gets 197, they essentially counteract each other. Okay, so looking at our week 1 average carrying cost. We have an average carrying cost for, this is the single machine we are talking about here, of $350. Standard deviation of 483, which is a rather large standard deviation. The average penalty cost is 1,300, and the standard deviation of that is 1,700. These are very large standard deviations and large penalty costs, especially when we compare these directly to the machine of week 2 where we have 10 machines. So the average carrying cost is, you know, 3 times smaller, more than 3 times smaller, I'm sorry, than the average carrying cost of the one machine. And then so on, when we look at the average penalty cost, it is much smaller as well. So those are very important things to take a look at. Another thing is I created this is a chart showing the orange dots show the 10 machine average daily output, and the blue dots represent the one machine daily output. As you can see, the average daily output of the orange dots is all right around 1,000. However, there's one outlier. We're going to see outliers. It's pretty normal, but overall they hover right around the 1,000 range. When we look at the blue dots, it is all over the place. I mean, it could be anywhere from this being, you know, 53 units to 1,948 units. I mean, that's a very large variation, so that's not as good. We would want a smaller variation so we know what we're going to get on the average daily basis. We go over to the deliverables. So the average of week 1, which is the one machine daily output, is 984 units, while the week 2 10 machine daily output is very, very close to 1,000, what we're looking for. So in that case, it also beats it. This is a histogram of the week 1, which is the one machine of the output. What is between here? Between 17 and 447 out of the 100 days they completed, they were in that range 21 times. So essentially we'd want to be here the most, and we're also here 21 times. This has the range of 877 between 1,307. So we probably want a higher number here. Well, we don't. But looking at the 10 machine daily output, they have this occur 30 times. And although it's only 9 times more out of 100, which isn't much, it's only a 9% increase. When we look at the two far rights and lefts, in this case between 600 and 700, it's only occurred 5 times. And when we look at the 1,300 to 1,500, this only occurred 1 time, which is very good news. So then essentially the question is, what should we do? What is a better method? And it's very clear that the better workstation would be workstation 2 with 10 machines. The cost average is much lower on average, and this is to a far low variability comparison to workstation 1. The workstation adds together 10 random variables between 0 and 200, creating low variance because, as I talked about before, if one is low and one is very high, they get to counteract each other, and that's a big deal. The implications of replacing a group of machines with one flexible machine of the variability of the machine is almost always going to be higher. When you rely solely on one machine, multiple things can go wrong. You're relying just on one machine. If the machine breaks, you're kind of sitting there with nothing to do, no output. While if one machine breaks in the 10 machine process, you're only losing 10% of your daily output. So all in all, it is very clear that you should use the 10 machine workstation because the average carrying cost is less, the average penalty cost is less, the daily output, you know exactly what you're going to get. It's going to be right around 1,000 daily. And for those reasons, I recommend you use that workstation.